In this problem, we have to make a sequence of length 2 to the m plus 1 such that it has every number between 0 and 2 to the m minus 1 twice, and that since each number is there twice, if we find the first number and the second number and we XOR all the numbers in between those numbers, its XOR will equal k. So what on earth does that even mean, right? So let's set m as 2, right? That would mean the overall length would be, so that means we would have numbers between 0 and 3, right? Because 2 to the 2 minus 1 would be 4 minus 1, which is 3, right? And we would need that twice. So we'd have a list of like 0, 0, 1, 1, 2, 2, 3, 3, right? And so that takes care of this. However, if two numbers are the same, if we XOR all the numbers in that range, it should equal k, right? So right now, if we look at 0, we find the other 0 here. XOR these two numbers is 0. 1, 1, XOR these two numbers is 0, right? So wait, so the first thing to just know off the bat is if we XOR two of the same number, it's 0. So like 5 XOR 5 equals 0, right? If they're two of the same numbers, we get 0, right? So let's just make this general and make this x, right? And the same logic, if we do any number XOR 0, you just get that number, right? So there's that. So now let's say in this case we wanted k to be 2, right? That would mean for, like, let's say we have a 2 here and a 2 here. If we XOR all the numbers, they should equal 1. So then we'd have a 1 there, right? So now 2 XOR 1 XOR 2 would basically 2 XOR 2 cancels out, so we're just left with 1. So this works, right? And then if we had a 3 here and a 3 here, that would also work because the 3s would cancel each other out and the 2s would cancel each other out. And then same logic with the zeros here and here. And then where do we put this one? So let's say this one has to be outside the scope of everything, right? So we leave it here. But will that work, right? So what is 2 XOR, so this, right? So let's see that works, right? So what is it? 1 XOR 2 XOR 3 XOR 0 XOR 1. That's 1. That works, right? But that isn't always the case. And why is that? So this works because luckily it falls under something else. So if we XOR all the numbers, let's say from 1, 2, 3, all the way to sum 2 to the m minus 1. Let's do it. Yeah, 2 to the m minus 1, like that, right? So the key thing to know is this is true. The XOR from any number to 2 to the m minus 1 is 0, right? But this is only true for m is bigger than or equal to 2. So there are some edge cases we'll have to handle, right? So what does that mean? So that means if we take out a number, that will be our answer. So to put that more clearly, if we do XOR of 1, 2, 3, 4, all the way till, let's say, 7, right? Because 2 cubed is 8, 8 minus 1 is 7. And sorry, I missed a number here. 5, 7. So if there was a 6 in here, like this equals 0 is true. However, if we take the 6 away, this is going to equal 6. So for whatever number is missing in that list, that will be the XOR of all those numbers, right? So now we have that. So how can we make this list? So what we can do is you can say, okay, we could first put all the numbers from 1 to all the way until 2 to the m minus 1 in this list. So 2 to the m minus 1 in this list, right? However, we don't have k in this list. So there is no k in this list, right? So this is a list without k, right? And then what we can do is the exact same list so then we put k here, sorry, and then we do the exact same list but backwards, right? 2 to the m minus 1 all the way to 2 1, right? And then k. So why will this work? So if we just look at the ones, so in the range of all the ones, we'll have two ones, two twos, two threes, two of everything, and only one k. So that works. Using the same logic, let's say we pick 3, right? The 2 then 1 won't be affected because the 3 is in front of the first 1 and 2 and is behind the last 1 and 2, right? So then in the range of all the 3's, we'll have 2 3's, 2 4's, 2 5's, all the way until 2 of 2 to the m minus 1. However, we'll only have 1k, and using this rule, the XOR of that range will be k. So that's great. So now if we look at this, right? In this, since we have a k here, let's look at this, right? Let's look at this first. This would be the XOR of all the numbers from 1 to 2 m minus 1, because we have this k here also, and we know that the XOR of all these numbers is 0, right? So the XOR of all these numbers is 0, and then we add a k at the end. So 0 XOR k, which we know from here, is just k. So therefore the XOR from k to k is also k. So then that works out perfectly. So that's basically the whole concept to how to solve this problem. So now we need to tackle all the edge cases, right? So we have mk, yeah, and then cn mk. Okay, whoops. Okay, so first edge case. So let's say k equals 0, right? What does that mean? I think we have a test case here. Okay, yeah. K equals 0. So we always want the XOR of any range to be 0. But we know that the XOR of two of the same numbers is always 0. So if k is 0, we can always pair up two numbers next to each other. Two of the same numbers next to each other, right? So let's say we have a billion numbers, right? And k equals 0, we can always do the pairing of 0, 0, 1, 1, 2, 2, 2, 3, 3. Because the XOR of any range of the same numbers is always going to be 0, because the only numbers in that range would be itself. So 3, 3, 2, 2, 1, 1, so on and so forth. So then what we can do is we want to output the sequence itself, right? Yep, okay. So then we go for I between 0 and 2 to the m minus 1. We want to see out I, and then go on to the next number. Okay, so that's the first edge case. So else if m equals 1. Why is this an edge case? So this rule of if we XOR all the numbers between 1 to 2 to the m minus 1 equals 0 is only true for m that's bigger than or equivalent to 2. So if m is 1, we have an edge case, right? So if m is 1, would it ever work? So if m is 1, that means what? 2 to the 1. So that would mean you just have one number, right? So that'd be 0, 0, right? So if m here is 1, 2 to the m minus 1 would be 1. So that means we only have 0, 0. And the only way this could have an answer is if k is also 0, right? Because the XOR of these two numbers is just 0, right? But if k is any, and we handle that case in this if statement, right? However, in the case that we get m as 1 and k is not 0, then there can never be an answer because it's always fixed that the XOR of 0 and 0 is 0. So therefore we would just output minus 1. So else if, what's another edge case? What if 2 to the m is less than or equal to k? Yeah. So why is that an edge case? So if 2 to the m is less than or equivalent to k, then none of the numbers we have will ever be k. They'll all be 0 to some number that's less than k. and then this never holds true. Well, this, yeah, this only holds true if k is less than 2 to the m minus 1, right? If this is from like 1 to 8 and k is like a billion, like that would never work. So the key thing is that we need to see k as one of the numbers in this sequence. If we don't see this number k, then we can't really handle that. So therefore, we would just output -1. I think those are all the edge cases. Okay, so if all of that is not the case, then we do what we said above. So for I between 0 to 2 to the m, yeah, 2 to the m minus 1, sorry. What we do is if we see k, we don't do anything and we just continue. Oh, whoops, don't spell. Otherwise, we see out I. Then we would see out k here, like we did in this case. So we have done this so far. Now we put in k, and then for int I equals 2 to the m, right? What is it? 2 to the m can be 17. What's 2 to the 17? 2 to the 17. Okay, yeah, that's still an integer, so it's fine. So power 2 to the m minus 1 while I is bigger than or equal to 0 minus I. We would see out, oh, whoops. So if I equals k, continue, else see out I with the space afterwards. And so now we have handled this, and this. And then at the very end, we just see out k. And that should work. Yep, that works. -1, that is correct. There should be -1. Okay, and then the one that worked for us was, what is it? 3, 1, right? Does that make sense? If you look from 0 to 0, it's all the numbers twice except 1, so that would be 1. Same for 2, 3, 4, 5, 6, and even for 7. And then for 1, it's the XOR of all these numbers. So it's everything except the 1. Okay, that looks good. Okay, so you submit. And voila.